Okay, let's go now to the next differential equation, the Bernoulli differential equation. dy dx plus function of pxy is equal to function of fx y to the power of n, where n is any real number, is called the Bernoulli equation. So this equation came from, if n is equal to 0, then this equation is linear. So now, for y is equal to 0, is not equal to 0, this can be written as y negative 1, negative n, sorry, dy dx plus px y 1 minus n is equal to f of x. So f of x. So this equation, if we let w is equal to y 1 minus n, where n is not equal to 0 and n is not equal to 1, then dw dx is equal to 1 minus n y negative n dy dx. So with this substitution to this one, we simplify to the linear equation with dw over dx plus 1 minus n px w is equal to 1 minus n f of x. So as you can see, this equation, solving this equation for w and using y to the power of 1 minus n will lead to the solution of the Bernoulli equation. Now let's go to the example of Bernoulli equation. So example, y prime plus y over x is equal to ln x y squared, where that has an initial value of y1 is equal to 1. This means that x is equal to 1 and y is equal to 1. As you can see, you have to solve the initial value problem. So we can write this one as dy dx plus 1 over x y is equal to ln x y squared. So as you can see, this is in the form of dy dx plus px y is equal to the function of x y to the power of n, where n here is 2 and px is 1 over x and function of fx is ln x. So now first we have to let w is equal to y 1 minus n, where n is 2, so 1 minus 2 is negative 1, so 1 negative 1. So now next is dw over dx minus 1 over x, dw plus 1 minus n p of x w is equal to 1 minus n f of x. So we have to write this equation to this equation, get the initial value problem. So now solving this one, we continue, so it becomes dw over dx minus 1 over x, which is our px, and negative because 1 minus n is negative 1. Then w is equal to negative ln of x, which is our f of x, negative because 1 minus 2, negative 1. So now we have to get the integrating factor of this equation. So let v the integrating factor. So e to the power of negative the integral of 1 over x, which is the px or integrating factor, dx, which becomes e to the power of negative ln x is equal to 1 over x. Now this is the integrating factor, and next multiply both sides the integrating factor in this equation. So becomes 1 over x dw dx minus 1 over x squared w is equal to negative ln x over x. And now next will be the dx of the integrating factor times the w, which is equal to this one, negative ln x over x. Then integrate both sides. Integrate this by dx. Now to get the integral of this, we let u is equal to ln x. So du is equal to 1 over x dx. And now this will become negative of u du. Now du. So integral integral of this will be negative 1 over 1 half, negative 1 half u squared plus c. So integral of this one will be 1 over x w. So now w, so u squared is equal to ln x, so substitute 1 over x is equal to negative 1 half ln x squared plus c. Then since our w is equal to y to the power of negative 1, so substitute, this will become 1 over xy is equal to negative 1 half ln squared x plus c. Then to find y, our y now will become y is equal to 1 over x c minus 1 half ln squared x. So remember that we have an initial value of y1 is equal to 1. So substitute x is equal to 1, y is equal to 1. So now we get here, this will become 1 is equal to 1 over c minus 1 half ln squared of 1. Okay, now since this is 0 and 1, so it becomes c is equal to 1. So our c now is equal to 1. So our initial value problem, our solution will be 1 over x minus 1 half x ln squared absolute value of x. So this is now our initial value problem.